So, hello everyone. Welcome to my session for the Data Platform Discovery Day. I'm going to be doing a data session on Azure Notebook and data science fundamentals. So what I'm going to be doing today is just describing to you seems to be quite a bit of a lag, there we go, show you how to use some of the kind of technologies like Azure Notebooks, Jupyter Notebooks, be able to use the Python language and some of the libraries like Pandas and scikit-learn to build our data science projects. I'm going to introduce you to a number of other resources as well, so that you will be able to kind of continue on your learning after today's session. On the screen, you'll see that there's a few links that's in my Jupyter Notebook that I've made available today. So I've kind of prepped this up and made it available, and we're going to focus in on running through the content of this. But if you want to clone and follow along, there is a URL there, which is the notebooks.azure.com, and it's Neil S. Hambly projects, and it's DPDD-2020. So kind of I'll come back to show you that as well later. I'm going to put that link also into our chat window, so you have that available to kind of share around with all of the students. Okay, so first off, let me kind of explain what we're going to do in this session. It's about a 50-minute session. We will go through, say, kind of how to prepare some data. We're going to ingest some, in this case, CSV data, some flight data. We're kind of trying to make a little data science project around kind of predicting what are the best times to fly, which ones are maybe going to be predicted as maybe a late arrival. So we're going to ingest some data, and we're going to do some preparation on that data. We're going to cleanse it. We're going to do some kind of EDA, exploratory data analysis. We're going to explore the data, understand it a bit better, and then we're going to create a machine learning model to predict, basically based on information we already know, historical data, what might already be kind of the next stage. So let's kind of start with Azure Notebooks. Azure Notebooks is a free service. I'm going to break a new URL, which is notebooks.azure.com. So if you have not used this before, you can go to this URL, and essentially you can sign up for the free service. I'm already logged in, and I have a number of project provisions, and you'll be able to clone that project from today. Essentially, I can go and see the different projects I have, and right at the top here, if I zoom in a little bit, you'll see that we have a project for today called Data Platform Discovery Day 2020, and I've given you the link in the chat window to be able to go and clone off that. I'm going to step into that one, and essentially this is the main file I'm going to use. So let me just go into the project and show you I have my main file. I've got my backup as well. I've got some flight data, which is a CSV. And also, I'm just going to kind of go and grab it, and let me just minimize some of my screens here. So I can go to, sorry, this one here. I've got an additional set of, get my collections. I've got some additional information in a collection, which is websites available. So I've got all the information we need. Here's the agenda for today. So that's in there. I've got the project that we're working on, that's already in there. And I can share this collection as well. I'm going to look at also some other resources that I use for other materials that I train and deliver workshops on. I have one actually later today, which is our week 2 of our data science project for the Microsoft Reactive space. So I'm going to go through some content. But there's some additional kind of information I've gathered that might be useful for you to start your preparations. Okay, but let's go back and actually look at the project itself. So what are we trying to do here? Well, first we're going to do data preparation with Pandas. Pandas is a Python library that we're going to use. It's very common, and it's usually known as PD. So we will import the Pandas library. We will alias it called PD, and then we're going to use one of the functions, read CSV, to ingest a CSV file, and then we're going to examine it. So I'm going to walk through this. I'm going to go and grab the data first. Then I'm going to go and do the import, and then I'm going to read the data. So let's kind of do those first couple of steps. So I'm going to do Shift Enter, which is kind of run, or I can do that on the menu. And it's just ingested that data very, very quickly. So it's put some flight data.csv into my local project folder, which I can go and examine. I can go and see that I have some data in that folder. And there's my flight CSV data. Okay. Let's import the pandas library, and let's go and then to read that file, and we're going to create what's known as a data frame. So this is a very common kind of activity we're doing. So we're focusing on certain kind of common kind of activities we'll do, and then we're going to do data frame.head, which gives us 5 of the first 5 rows of red. So let's kind of run that. Shift Enter again. And you notice that it kind of has a number now in the box next to it. So this is kind of, I've done a couple of runs this morning just to make sure it worked. And I have my first rows, and it starts with a 0-based array. So 0 to 4, 5 rows, and I have 26 columns. So you can see 5 rows by 26 columns. And you can see the last column has this kind of NaN, which is not a number. Essentially, it's a null in that sense. So we're going to skip to the next one. By the way, there's a combination of what we call markdown cells, which are the ones in this kind of green color. There's some add colors as well. And the ones that have, like, to the left of it, this kind of and in this case, an open set of brackets. This means I have not run this yet. Now, the df.shape is going to say to me, what's the structure of this data frame? I have 2 numbers, 11,231 and 26. That means I have 11,231 rows by 26 columns. Excellent. So I know a little bit more about the data now. And I've used also this typical kind of a statement I do is data frame is null, parentheses, values.any. So is there any values in my full data set, this 11,000 or so rows, that has any NaNs, any missing values? Yes, it is. So that means I'm probably going to have to do some cleansing operations. And very typical, we're going to see this as something that we need to have to do to cleanse. And usually that 60, 70 or more % of a project is actually the preparation phase, getting the data to the right state. We're doing something called feature engineering. We'll do a exploratory data analysis. We may do a principal component analysis, a bunch of different data science processes there. Let's look at the values we have. So df.isNull, not sum, is kind of give me the count for each of the column names, how many nulls. So you can see, like, you know, there's a few nulls in the department, time, delay, etc. Right at the bottom though, we can see that there's unnamed 25, and it's got 11,231. Funny enough, that's the same number of the rows. What that means actually is we probably have a comma at the end of each line in our CSV. So we kind of have this additional kind of, you know, just comma and nothing beyond it. So we got all these not numbers. So we want to kind of drop that. We want to remove that column. So I'm going to use one of the other commands, functions called drop. I'm going to name the column I want to drop. Axis, I'm saying, is a row or column. So in this case, it's a column that I want to drop, and I'm going to run that. I'm going to do the is null sum again after it, so kind of repeating that. And now I can see that no longer the last column we have is distance. So we kind of remove that unnamed 25. Excellent. We kind of have removed something that we don't really have any value. But we also have a, sorry, go ahead. Yep.
Some people are asking if you can enlarge your screen a bit. They have some difficulties viewing all the data.
Okay, let me see if I can kind of just make a few, let me go back one level. So does that help at all? I've kind of jumped it a little bit, but I just need to be able to run it and keep stuff on the screen. So hopefully that's helped a little bit.
Yeah, thank you.
Cool, okay, thanks for letting me know. Okay, so we now got an additional way of filtering out columns, or to say, here's the columns I'm interested in. So in this case, we want month, day, week, origin, destination, this departure time, and this arrival delay kind of flag. So let's kind of run that. And we can see that we have, again, for those columns, we have the arrival delay 15 minutes, 188 values. So we have a number of options here. We can say, you know what do we want to do? Do you want to include those rows and kind of do something with the nulls? Do we want to kind of, zero them out or something? In this case, what we're going to do is we're going to kind of have a look at the values first. We can see that these are the kind of end of the rows that we're looking at. So kind of we can see that kind of not the end of. We found some rows where it's not a number. So we kind of filtering essentially at this point for that, and we're finding just a lot of numbers. So what we're going to do now is we're going to do the fill NA function. Okay, and what that's going to do is going to replace it with a value of 1. So where it's not a number, so for example 478, it will have 1 as a value. So we're going to say, we're going to replace those. So let's kind of do that now. And what we've also done now, also after that, we said, I want to see between the rows 177 and 185. Give me kind of a section of it. And I can see that we would have probably have 187, sorry, 177 and 184, 179, 184. These kind of now have a 1 value in there. So we know that it's done what we've asked it to do. Okay. I haven't gone to every single kind of step that we would have probably gone through to do that. I'm kind of showcasing a few of the example steps that we're going to try and do here. But one of the things also I want to do very often is I'm going to convert my categorical variables into some indicator values. So I want to show you what I mean by that. First off, I've got those columns of interest, and I'm also going to use a different library called math, because I want to be able to use some kind of the additional kind of functions called floor. And what I want to do is, you see we have 1905, 1345, 940. Well, this is a 24-hour clock, so 1905 is 7:05. 1345 is 1:45. So we want to actually remove the kind of minute components, and we just want to leave 1900 or 19, 13, 9, 8, etc. So what I'm going to do is I'm going to use this kind of a calculation here. I'm going to run this. It's importing the new module. It's going to then iterate through all those 11,000 rows. It's going to convert this CRS depth type to essentially remove the kind of the minutes from that. So we should end up with 19, 13, 9, 8, and 23. Okay, so wait for that to finish. Usually takes about 30 seconds. There we go, and we can see that the values have now trimmed those kind of those minutes off there. Excellent. I'm going to use this code here, the get dummies code, to kind of create the indicator columns that we want for, and then I'm going to drop those two. So I'm going to use it first, and I'm going to drop those columns afterwards. So kind of let's kind of do that. So what I've done is I've got the original kind of values, and I'm all good to go. So it's going to use them and then drop them. So kind of we've got the origin ATL, origin DTU, so for each of them, and then we got the essentially the destination ones, and we got the kind of values that are associated to that. Okay, there's a little bit of an explanation below, but essentially what we're going to do now, let's say there's a lot more steps that you probably would do with cleansing the data, but we're going to start quickly building a machine learning model, and we're going to use one of the very popular kind of libraries out there called Scikit-learn. Okay, I'm going to show you where you can kind of learn a little bit more about those kind of capabilities and different links to help files, etc., that we might want to kind of also use. But right now, at the moment, what I'm going to do is I'm going to bring in the model selection kind of feature. I'm going to import the train test split kind of capability to essentially split out the data for 80% towards the training data set. I'm going to leave a remaining 20% for the test size, and we're going to then test our model accuracy, etc. So there's a couple of things we need to do. First, let's run this. Didn't take very long. It's a very small model that we're working with in terms of data, and this random state, by the way, is just ensuring that we get the same value on each subsequent run. So I could change that random to a different number, but it's essentially enforcing that we get the same kind of random selection each time, so the numbers are represented the same each run. I'm going to want to look at the kind of number of rows and number of columns we have in our training data set. And I'll do that. And I also want to do that for my tests. So I've got 8984 from the 11,000 and 2,247 from my tests. So, you know, there's an 80-20% split roughly there in that number. Now, what we're going to do is we're going to choose one of the regression models to play with. There's a large number, and I'm going to show you where you can kind of find more about that in some other resources. But essentially, we're going to use the kind of the binary classification model in this example. Sorry, the random forest classifier, and we're going to try and predict the outcome of whether a flight is going to be on time or will be delayed based on historical information. So let's kind of start this one. We're going to do the run. We got a little bit of a feature warning because it's changing some of the context, so ignore that really with the feature warning. But what we have now is our default values that have been specified. So, you know, what the leaf level is, what the minimum splits, etc. We don't need to worry too much about that. We're just kind of using that specific model at the moment to evaluate our prediction. So let's have a look at our prediction itself. So we're going to use the predict method. And then we're also going to look at the score method to actually understand the accuracy of the model that we're using. So we're doing predicted equals model predict, and we're using our test data set. Clearly, we need to test and predict on our test, and we want to score them on our test environment X and Y. So let's go and run that. And we end up with a 86% accuracy level. So, you know, doesn't sound too bad. But is that a good, reliable indicator of the accuracy for classification model? Maybe, maybe not. Let's go and explore that a little bit further. And we'll look at some of the other kind of ways of scoring and looking at the accuracy of our models. And one of those is our receiver operating characteristic curve, our ROC curve, and the area under the curve. And you may kind of remember back in your kind of math classes where you're trying to predict kind of that elbow as high into the far corner to get kind of the accuracy level. So the higher the elbow is, and we're going to look at some kind of graphs to describe that as we go. So let's kind of look at the actual ROC AUC score. Again, it's coming from the scikit-learn module. We're using the metrics function, and we're going to import the specific kind of capability to look at probabilities, being this probability predict or predict underscore probe a function. So let's kind of run that, and it's done. You know, I kind of need to see what that's all about, so I need to then call that. So I'm kind of using this ROC underscore AUC score. I'm going to look at the probabilities, and I'm going to kind of look at the scoring that we have. So we generate that score. We have a 67%, 67.4 in this case, accuracy. Well, that's a little bit much, quite a bit lower than the original kind of 86% we had. So, you know, it's maybe not quite as accurate as we may have kind of predicted. And we want to maybe understand that. One of the ways we kind of review the accuracy of a model is using the kind of generation of a confusion matrix and error matrix. We want to look at the true positives, the false positives, the true negatives and the false negatives. And we have this classification or confusion matrix that kind of gives us that understanding. So let's have a look at that. So let's kind of import now our confusion matrix and look at that one. Okay, so we have one that is giving us thing. Now let me explain what we have here. On the top, we have our trues, and on the bottom, next line, we have our false, or negatives. Here we're saying this is the true positives. Remember, this is the test data set. So we have about 2,200 rows, and 1,882 were actually true positives. So a very good percentage. There were 54 true negatives in that we incorrectly predicted the outcome for that. In this case, what we also have is we have a false negative and a false true positive negative as well. So these are the values, this one in the top left and the one in the bottom right, should be high. And we're looking kind of for zeros really in these kind of opposite levels. Well, we can see that kind of, you know, it's actually in some cases, it's not kind of, sorry, we can see that kind of we've got quite a high set of numbers here. So let's have a look at kind of another way of understanding the precision level or the accuracy of a model. Because at the end of the day, we can create some code, we can cleanse our data, we can put that data into our model and do our predictions. But if the accuracy level is not there, then it's not really going to be a great kind of a predictor of outcomes, and we're not going to get the results we want or be able to get close to a good prediction, a good accuracy level. So let's have a look at what we have around precision score, which is another one of the kind of metrics we have available. And there's quite a few of them. I'm going to show you the kind of the Azure Machine Learning Service and show you kind of maybe some visual ways of interpreting this better as well. So let's run this. 99.7. So yeah, it's a good precision score there. But we also have a different one, which is called recall underscore score. So I'll show you where you kind of learn about more of this. Essentially, this one has 86%, so it's very close to what we had before. So far, we've not seen any visualizations of our data. So one of the capabilities we have inside of Python is this kind of matplotlib library, and we're going to kind of import that. We're going to import the pyplot kind of capability, and we're going to, this is quite commonly do that. And we're also bringing in another library called Seaborn, which is kind of a little bit better at kind of enhancing the output from the matplotlib ones. So we need to inline it first. We need to have that in front of the import line, run that, and then we're going to do the Seaborn and set. So let's run this. Okay, so what we've done now is we've set up the stage for being able to create our graphs. We need to now look at our rock curve, our receive curve, and we're going to now import that one. We're going to run it, and we're going to do these plots. So we're basically finding our false positive rate and our true positive rate, and we've got some colors. We can change this around a bit. But let me kind of run this, and here is the outcome from that. So we plotted some data. Now, what do we have here? Well, this is our 50-50 line horizontally kind of running through. And what we have then is the ability to see that the blue curve is essentially our plot on the ROC curve. And it's kind of actually quite shallow. It's kind of quite close to this line. We want it really up in the top kind of quadrant there, the top left quadrant really. So this is not a great number, okay? And we can see that we had the outcome of that. Well, we've got some data in our flight delay CSV. We want to now kind of make some determinations on that. So we set up the stage, we prepped some data, we've done some kind of manipulation on the data itself, cleanse the data frame. And now what we're going to do is we're going to create a quick function to actually predict the delay. So we're going to kind of create this, this function. We're doing departure, date time, origin, destination. We're bringing in the date time as a kind of function, so kind of we just need to kind of format it correctly. And then we're going to kind of create the parsing on the month, day, of week, and hour to kind of look at that departure, date, time value that we parsed. And we're also going to kind of uppercase our origin, destination. And what we're doing is we're kind of doing the inputs of this information coming from that data frame. Well, remember we did some information where we actually created the kind of the sets of data for both the origin and destination for some of the kind of airports here, so ATL, DTW, etc. And then we're going to run our model predict prob A on the data frame, and we're kind of just running this. So let's kind of run that function or create the function. So the function's created. We haven't actually kind of really done anything with it yet, but we created that function. We can now call it. few caveats about kind of the formatting. So if you are kind of one of those crazy folks that tends to like to do months and then days, then that's kind of just be aware kind of how we do things in Python is proper. So we want to do a prediction. We're going to do the predict delay. That's our function that we created. We're going to pass in 3 bits of information: our dates, our origin, and our destination. So there's our date, origin, destination, and let's see what we get. So we run this, and we have a prediction of 0.6. So 60% is predicting on the 1st of the 10th, 2018, at the 9:45 departure from JFK to ATL. We're going from a 60% accuracy in terms of predicting that this will be arriving on time. Okay, so a good chance it might be delayed. Let's look at that code and let's kind of move it forward a single day. So we're going from the 1st to 2nd. We kept the time slot the same, the locations, and when we run this one, according to the data we have, it's going to be an 80% prediction it's going to arrive on time. So now, hey, much probably better to run the next day if you want to kind of catch that connection or kind of run that. Let's have a look at a different one. We actually changed just the time, and also we're changing, in this case, the locations as well. And here we have 100% accuracy. So it's saying that a morning flight on the same day of the 2nd from Atlanta to Seattle, is going to be predicted to be 100%. And obviously, nothing's always 100% prediction, but we look at the data, we think that's prediction. Now, if you're kind of planning routes and doing all this, you might want to take the historical information about which airports run and how late and how often they're doing, which flights specifically on which days, with which airlines might be kind of delayed. You may find a better set of routes, and we might want to use this machine learning kind of information to predict which routes we're going to kind of want to do, and then be kind of then decide on one set of routes versus the other to get to our destination on time if we have maybe multiple hops even. So kind of when we're going to do this for a number of entries. Now we're introducing that second or another very common library here. And this library is called NumPy. So NumPy is the numerical kind of Python. It's all about statistics and kind of that. And what we're going to do is we're going to create some labels. We're going to input our data set. So we have a set of 7 kind of sequential days with the same flight on each day. And we want to arrange that and see what the kind of, which ones are more accurately kind of predicted to be delayed or not. And we're going to then plot that out. So we're going to use some bar plots. We're going to kind of create that. Let's kind of run that. So what we have is scroll down a little bit and have a look at the graph itself. We can see from the 1st of October to the 7th, we have really the 4th is the best day probably to kind of run that. Then kind of the 2nd, 3rd, or 5th is probably next, and then we've got the 7th, and then we've got an equal tie for last place being the 1st or 6th. So I'm going to probably say the 3rd to the 5th is a good time frame day-wise, if you have choices to actually go and run your kind of your flights on those days, as opposed to maybe the 1st and the 6th. Okay, so we're using the matplotlib capabilities there. There's more teaching kind of links there to kind of show you what we have, but that was kind of a quick kind of example of a Jupyter Notebook. But I'm going to show you some more examples, and one of the ones I'm going to show you now is ones from my kind of projects or kind of workshops I do for Microsoft, and they're called the Data Science Reactive Workshops, and we have a number of them. And this is where we can kind of go in and look at kind of some more details about cleansing and manipulating data, kind of doing specific steps for NumPy and Panda, so more in depth there. I'm going to show you where all of these projects are. So I'm going to first off skip over to my Edge. I'm going to go to the main GitHub for the Reactive Workshops. Now, what this is a GitHub repository for all of the workshops that I'm doing or myself and others are delivering at the Reactive Workspaces around the world. And the moment I was doing a delivery yesterday, I've got one more today around the data science, and we're kind of doing the NumPy and Panda. So I'm going to show you some of the examples. I'm not going to go through all the steps, but I'm going to make you aware that you can go and download this material and go and grab this. So we have introduction to the technology, explains how to do some of the tasks, how to use arrays in Python, so how to create these NumPy ND arrays, how to perform different things like creating lists and dictionaries, and lots of really cool, very easy to use kind of functions. So we'll kind of show you some examples of that. We're also going to just go back to where we were on this one for a second, go into the pandas as well, and to show you that there's a very similar kind of workbooks there to be able to work through around kind of creating series and other objects inside of the pandas libraries, and be able to do some graphs and other things. We can create things like dictionaries. And we're going to run that one. That's going to create, I need to actually just do my first import. So I'm just importing the library. So pandas is commonly done as PD, NumPy is NP. That's running. It's got a start. It's now gone to a number. It's running. It's run there. So we kind of, I'm also bringing NumPy as well. And now we can kind of, I can walk my way through some of these kind of steps. It's going to get down to a couple of examples I want to show you. Further down, this one here. So I've got the PD series where we've actually created this kind of dictionary list. So something you might want to do where you're going to create arrays, multi-dimensional arrays or series, we can kind of create these really easy. And we can also pull back all the values. So I wanted to pull back what the population was. So you have the ability to walk through these kind of these workbooks, learn from them, and kind of evolve them. But also, I think kind of the really cool thing I find is that if I go back to the data science reactors, we'll scroll down a little bit further, go back to the GitHub. Oh, I was on the wrong one, so there we go. Go to my GitHub. Reactors. If I scroll down, we have descriptions about all the workshops, but there's also all the slides, and the slides have some great information about what's inside of kind of the Azure Notebook environment, how to create Python scripts, how to write pandas and NumPy code. So there's some great learning, but there's also another great place to go and start learning all this. It's called Microsoft Learn. So I'm going to go to my link for my Microsoft Learn. I'll start with this link here. The wrong one. Where's Microsoft Learn? Okay, I'll just type it. Yeah, I just updated one of the links by mistake. So Microsoft Learn. So Microsoft Learn itself is a great website that you can kind of go and browse a great deal of content. There's a large number of modules and information. I'm going to focus you in on kind of the roles that we have. And if I go to data scientist or data engineer, I'm going to do data scientist today. I'm going to show you that we have still quite a large number of results sets, but I'm going to scroll down and say, look, you want to start learning machine learning with Python and Azure Notebooks. There's a 2-hour learning path. There's other modules that take you into other resources. So I'm just going to click onto this one very quickly. Because what I've done is I've used this analyzed climate data with Azure Notebooks. There's predictive flight data, so we use this in the example I wrote. And this is kind of takes you through the steps on how to create projects, how to kind of ingest data. Do that. So the steps inside of this specific module is the one that I recreated inside of this one here. What I've done is I've done all the steps, and I've also kind of created a bit more instructional information around that as well for you. Okay, so we have all the instructions. You can step yourself through that. It tells you kind of how long it's going to take. It takes you through all the steps. It explains it. There's a bit more probably detail in here than I put in the Azure Notebook itself. But you can kind of walk your way through, understand what's happening, and get to each of the sections. Kind of get down to the bottom for a second. Here we're building the machine learning model. And I'm just going to go, and then we've got the output of the model. We can see the visualizations. We can explains it in more detail about which ones we have and what's kind of good. And then finally, in a lot of the examples, you have a check your knowledge section in this around the summary at the end. And it's going to say, did you understand what you've gone through? So you might be, okay, let me look at the method used. We've got load file, read file, and read CSV. Well, it's read CSV in this example. What is the purpose of splitting data? Well, not to give the data too much model. The model doesn't need too much data, or one part can be used for training and the other used for evaluation. So we're going to choose this one here. And then finally, PLT bar, PLT chart, or PLT bar chart we want to do a plot of bar chart. Well, it's actually this one because this thing doesn't exist at the bottom. Let's check our answers, and we're all good. We've got the correct answers. We can go on to the next module. And then it will kind of take you to other examples. So in this case, you might want to create and train a neural network. And it tells you how long. So there's some great resources there about how to go and train on kind of the technologies using the Microsoft kind of learn environment. But you may also want to start saying, well, look, I'm going to do all this training. Maybe I want certifications at the end of it. So we can browse the certifications. And if I look down, there's a number of certifications, quite a lot, and they're constantly changing. So if we look down, there's going to be one around the DP100, if I can find it. Here we are. Designing and implementing a data science solution. So this gives you more information about kind of how to approach doing things around data science, workspace, etc. And what you do now is I'm going to show you the machine learning workspace and studio and service, and show you some of the things we can do around that. So this is a Azure service. So I'm going to Azure machine learning service. So I'm going to log into one of my machine learning environments. Okay, I'm going to go to my service. Oh, wrong one. So this one here. And I'm going to log into my machine. I just want to show you that there's kind of some free materials and free resources around some of the Azure environments that we don't have. But we're going to go to portal.azure. I'm just going to log in, and then we're going to go to create a resource. And in there, we then have a kind of a list of different marketplaces. And one that we are going to be interested in is spin up an AI machine learning service. So click on that, and then you can see a whole bunch of them there. The one that we're interested in is the right at the top, this machine learning. It looks like an icon of a flask. I'm going to click on that one. And this then explains what we have. I'm basically going to create a quick workspace, so DTPD 2020. I'm going to create it in a new resource group, so I'm just going to kind of just grab a new one there and called DTPD 2020 RG for my resource group. And I don't really care kind of which region it's going to be in. I'm just going to go enterprise and review and create. So you can see how quick this is actually being provisioned. And then when we got this workspace or kind of machine learning service for visions, we'll need to click on the create. That's a useful item there. It's now going to initialize that deployment. It will take 2 or 3 minutes to bring the service up. And then I'm going to launch that. And I'm going to go into a different browser window. I'm going to show you some of the real estate around machine learning services. So if you get into data science, it's great. We can do these Azure Notebooks. One of the things I want to show you is we can do those notebooks inside of the machine learning service. So we'll let this kind of revision up for a second. While it's doing that, I was going to say, is there any questions that have come through that I can answer while we're revisioning this up?
Yeah, we've got a couple questions.
Okay.
Let's see. The first one is, why are we dropping the minutes from the times?
The reason being that I dropped the minutes from the times on that because essentially I didn't, the accuracy level just needed probably to be the hour. So which hour, when I'm kind of graphing it, I just want to see which hours of the day are kind of problematic. Minutes gives me too much detail. And kind of, I'm trying to group those flights into a kind of hour category, if that makes sense.
Yeah, I think it does.
Okay, so I'm just going to go to my my machine learning service. So if there's another question, throw it up. I'm just going to launch this now. So it's going to launch into ml.azure.com space. It's going to provision up my empty kind of machine learning service. There's some great kind of start the tour about registering data. I'm going to show you quickly some sample data sets as well. So kind of just click through those very quickly and just kind of come to done. And I'm going to do an automated ML. In the few minutes I have now, I'm just going to create a new automated ML run. And I'm going to create and use an open data set. Now, this is a new set of kind of open data sets, common kind of public data sets. I'm going to use the diabetes one. So I'm just going to highlight that, click next. I'm going to call it diabetes, but I can't spell, so I kind of always get it spelling wrong. There we go. I've got version 1, that's fine. So I'm version up my data. I'm going to make use of that one. I'm going to click next. And here what I'm going to do is I'm actually going to say, create a new experiment. So yeah, so ML auto, so let me do that. Auto ML diabetes. Again, I always seem to type the S there when I shouldn't want to do that. I want to get the Y column. I'm not going to go through all of the details there. And I want to use compute. So I'm going to create a new compute. I'm just going to give it compute. Oops. Compute 1. Virtual machine. I'm going to CPU. I'm going to do everything standard. That's kind of good. And click on creators. That's created now. Once that's created, I'll be able to create the drop down from that. And then I'm going to kick that one off, and it will take about 4 or 5 minutes to process through that data set. It's going to look at multiple machine learning algorithms and determine which one is the best. So when I was doing my kind of my example back here, I was going through and we were using one specific regression model. So if I wanted to try out like 20 different regression models and kind of and the hyperparameterization and other kind of different values I want to test with, that's going to take a lot of time and manual effort to do. So the AutoML is the capacity for us to kind of just give it a data set, tell it what type of opportunity. So we want a regression type model, and it's going to then go and kind of iterate through those. So we're going to see how that's got on. That it's kind of creating, that's good. So kind of close on that. I think we're kind of waiting for that to refresh. I'm just going to see if there's anything under compute now. It should be there at some point. It's creating it right now. So while it's creating that, let me go and look at the notebooks. We can kind of bring in a bunch of them. And also I have the ability to look at samples. So what I'm going to do, I'm actually just going to clone that samples for Python and R. So here we have the ability to also kind of do R as well. We can in the notebooks, but I'm just going to clone the Python one for now, put it in my directory, and I need to clone it first in order to be able to run them. I'm just copying the kind of templated values. These are examples that you can kind of run through, and I'm going to show you a few of those once it's cloned. And we'll be able to kind of spin up our Azure machine in the service, jump in, look at some samples, go to Python, and actually kind of go and look at how to maybe do our classification. Here's our first ML experiment. We can kind of look through some of those. So there's lots of options here, lots of kind of capabilities. So I'm just going to grab this first one here. And you see I have the Jupyter Notebook, had the IPYNB file. And we got the experiment one, and we have the training one. But also under Designer, so just click through a few of those. I have a bunch of, and it can put a second on the top of the screen. It will show you some samples. We can kind of go through, look at those. And these are more of a graphical, no-code version to build in your machine learning models, etc. Okay. I know we've got about 5 minutes left, or slightly less. I'm just going to wait for that compute to hit. And while it's waiting for that, let's go back to the main data science project. So if you wanted to kind of get a handle on data science, want to get started, I suggest you do start with the data science project we have. So let's go and bring that up. Oops, where was it? There we are. So data science 1, kind of gets you started, and there's the full day, which is kind of the full day class with all of the Jupyter notebooks you need and all the data and all the images, everything you're going to need to do that. And the slides, as said, are also a bit further down. You click on the link here to download the slides. Once you've done Data Science 1, you can go to Data Science 2. It's a little bit more involved. It has some additional kind of machine learning models and references. It's kind of a bit of a kind of next step after the Data Science 1. And then we also have 2 other workshops. We have Machine Learning 1, which introduces you to machine learning and joining data sets and doing something like a principal component analysis review, the ROC curve. And then on ML2, we have the ability to kind of go in a few more of the kind of algorithms like the k-means, regression 1, regression 2, naive Bayes, etc. We have these additional capabilities there. And we also have some Python files as well, versions of those. We might want to use those. Let's see if we actually have a. So let's go and have a quick look at Designer. Is it refreshed? One sec. Trying to push the envelope on getting things done in terms of times here. So we may kind of run out of time in terms of it finishing the example demo. To kind of wait for us to see that's done. So any more questions while we're waiting for that in the last few minutes, etc. Also, I'm going to show you where you can kind of get information over to me. So if you want to, let me go back up. If you clone this workbook, I'm available on Twitter. So if you go to Neil_Hambly at Twitter and you want to ask me questions about today's session or more, then feel free to connect in and DM me or kind of just kind of let me know. I'm also available on email, so you can kind of email me, and that's Neil. Let me go there. That's neil@beaconintel.co.uk. Again, it's the links in the there. LinkedIn. I'm on LinkedIn. If you want to kind of come and join me on the LinkedIn kind of platform. And there's a website as well that we can kind of have for beaconintel.co.uk that I kind of have some information. So just going to see if we do have any kind of results on this. Let's have a quick look. Wait. I think we might have to just think that we probably don't have enough time to showcase the screen there. Kind of just close that out and open it up again. Sometimes that helps. It's running in the background. I just want to see actually it has completed great. So I just want to kind of see that I can go and run that experiment, and we can go and see what the experiment that we ran. So quick look. AutoML. I'm not going to kick it off, but kind of I'll just show you that if I chose the diabetes data set next, put that experiment in there. So just put a new experiment. Target column Y, compute, I'm going to choose that. I want to show you this next screen because basically this is where we get to choose. I'm going to choose the regression classification, click finish. And this now is actually going to go off and run that full automated ML. And it will take about 10 or so minutes and more to kind of come back. And it would kind of create different algorithms and score them and evaluate them on the precision, recall, and accuracy. I can choose kind of the outcome. Finally, at the end of all of that, once I choose which is my model of choice, I can deploy it directly inside of that tool. So we have run out of time in terms of the kind of 50 minutes. So if there's any more questions, I can take those now, and we'll see if this information will kind of be visible at some point in this example. So back to the model.
We have some questions.
Yeah.
If you so
go ahead.
If the information is asymmetrical, how can the ROC be calculated so that it's more considered in the class that we have less information?
Okay, can you just read that out again, because it was kind of hard to follow that in full. Yeah.
So if the information is asymmetrical, how can the ROC be calculated so that it's more considered in the class that we have less information.
Yeah, so it'd take a while to explain that one. I just, if they want to email me, I'm just going to put up my notepad just to kind of and put my contact details on here. Let's kind of minimize it a little bit. You can forward on those type of questions to me. I'm just going to make it a little bit bigger. One sec. So Beacon Intel. And let's format that to be a nice chunky size. So if you want to send kind of emails through to me, it's neil@beaconintel.co.uk. Frame out your question, and I'll hopefully be able to answer them. It's a little bit more involved to be able to answer right now in there. But I've got these experiments running at the moment, and I'll kind of be able to maybe kind of give you some information about kind of example that might kind of fit your specific question. Okay. Any more questions we have there at the moment?
We have one more question. It seems to be related to your notebook.
Okay.
Why does your notebook look nicely presented? And you can run the code in line, but if I choose it in Azure, clone it in Azure Notebooks, the formatting is very basic.
So why does this look like this, and why is it, if you clone it, it doesn't look like this? To be honest, I don't know why the clone should be the same kind of, because essentially if I show you what kind of, if I click on it, what I've got is kind of the markdown, and I've got kind of some of the format, but this should be available in any of the versions that, so this is kind of using some kind of syntax inside of the notebook to kind of create some colors, create some kind of, I'm using the alert block, alert warning, or kind of info classes to kind of give me some kind of different colorizations, kind of a little bit of a green to stand out. I have some blue, I think red and blue further down in some of my colors. So this is purely down to me formatting this. This is me creating this from scratch and creating the code and the formatting. If you clone it, it should be the same that I'm aware of, because it's basically iterating my code. But yeah, I kind of created this from scratch yesterday for this session.
Maybe you can ask you on your email.
Yep, you can email me, and hopefully that will come through. Yeah.
Yeah. Okay. No more questions.
Excellent. So I'm just going to see if we have some of the models that kind of explained, so some of the details. It looks like that there's it's running, but it kind of hasn't got enough through at the moment to actually give me enough information about the models themselves right now. Yeah, I'd have to go kind of wait for this a bit longer. But look, I appreciate everyone's time. I know that you have choices of what you spend your time on. So being able to come to my session today and be part of the Data Platform Discovery Day and listen to all the instructors, that's a great thing. And there's some great sessions coming up. I'm going to be viewing some of those myself. If you want a copy of this notebook, you want to reach out, there's kind of how you do so. Otherwise, my thanks to everyone, and I'm going to let the next presenter get queued up.